first is the introduction of the project. The second is the products. We showcasing our product. The third is our artifact. Fourth are the achievements and the challenges that we face. The fifth is the plans we have for this system, and sixth is the last. And lastly are the team contributions. Firstly, our client, the AI lab from the Ho Chi Minh University of Science, is a lab consists of experts in researching and utilizing IoT, robotics, and AI to develop practical solutions in our everyday lives. Founded in 2015, it has become one of the major leading research labs in Vietnam. The AI lab came to us with a few problems. One of them is when they're members of the robotics and IoT club, while teaching at the iTech Center, they often forget to close the doors and lock them, leading to strangers breaking in and steal valuable goods. Furthermore, they also often forgot to turn off electrical devices such as lights and air conditioners, leading to problems such as wasted energy. It is a problem. It is also a hassle every time the security has to come up to report the lights being on or the air conditioners being on, so that the staff members have to go back up here to turn them off. So they would like our assistance in solving the problems. And our solution is to build a system that can monitor and handle the electrical equipment along electrical equipment along the doors in iTech Center. We call it the Assistant Electronic Devices Surveillance System, or AEDSS for short. The system will allow our client to monitor and control the appliances via a mobile app. Their statuses will be controlled via integrated circuits when transmitted to the cloud server, where the data will be handled and updated to showcase on our client's mobile app. Additionally, the system also integrates AI library to detect intruders using infrared lights and will report human presence and snapshot any intrusion. Images and data collected from our system will be processed by Raspberry Pi, a single board controller, and along with microcontrollers. Then the necessary data and notifications will send to our clients via their app. Additionally, our client can also manually control the device's statuses. They can turn on and off lights and air conditioners remotely. This data, when they request the action, the data will be transmitted to the server and controlled and requested by the microcontrollers to perform the corresponding action. Next up is
So to satisfy the demanding of not replacing on infrastructure system of the client, and moreover, we want to utilize our solution in the future. So we decided to develop a system that the user can only look and wait, and it can depend on what the features or what the functions the user wants. They can use only that component, and moreover, we can expand all the components and the device depending on the space. For example, if we in a small room, we can only use one or two components to control all the room. But in the larger room, we will make a research can make a decision to how many components we need to that room. So this is our device connection. In the center, we have the central hub. It includes microcontrollers and Raspberry Pi. In here, we have door, means door monitor. It will check whether or not the door is locked or not. For the PIR, is responsible for detecting movement. Here, it will use the heat. It will check in the heat movement outside the working hour. For the DHD and light sensor, this is the light detector and temperature observer, which will collect the current temperature in that room and check whether the light is on or off. For the relay there, it is the light switch which will turn on and off the light as demand. And the AC is also the AC controller will turn on and off the AC when the user needs it. And finally is the camera and servo component. It is in the surveillance system. We comprise a camera and two servos, which will control the camera angle and photographing on the system in that room. So here is our project. Here is our product's main feature. As we said above, we will control the system via a mobile app, and we will develop it into two platforms, Android and iOS. So here is these are the main feature of that. The user can remotely turn on and off the AC and light. The user can set a schedule to automatically turn on and off the light and the AC. The user can also check in the working state of light, door, and AC. The user can also receive notifications when a stranger breaks in or the door is not locked. And finally, the user can access the gallery to check the working state of the room status. So now we will demo our system to all of you.
Yeah, thank you for that. As you can see here, this is our final product, our system presented in a box. As a first layer, we have all these small components here which have their own label on them. Each of them have their own label which represent their role inside of the system. Here, we also have 3 microcontrollers that interact and control all these small components individually. And at the second layer, we have all these boxes here, we call it central hub modules, which we all store our microcontroller inside, and a single board computer, Raspberry Pi. And we have also deployed our system to the room G2 to show and to demonstrate how our system operates in the real situations. But before we get into the video demo, I have to provide some context on why we set up our system like this. Because we cannot directly deploy our system inside our school property, so we have to lay out all of our cables, which is not very authentic. However, they are part of the videos that we show that how our system looks when it can directly deploy to the system, to the room. Is the video?
Install the device in this room and turn off the light.
Like that, right? At first, we would like to introduce all these small components, but more in details. First of all, we have these assembled cameras here, like all these small parts that got assembled like this, that we can program and control them. DHD sensor is what we use to measure the temperature inside the room. Light sensor is used to detect whether the light is on or not inside the room. Here's the door, which we call it door monitor to monitor the status of the door is locked or not. Here's the AC sensor, which is used to control the air conditioner inside the room. We have PIR sensor. This is what we use to detect movement inside of the room. And lastly, we have a relay, which is our programmable light switch. The right side is central hub, where we store all of our microcontroller and a Raspberry Pi, which is our main operator for this system. is the look of our component with the cover. This is the white plan for the room G2 that we deploy our system to. We research and draw out the top-down view of the room to have the best optimal position for each module in our system. At the far end here, we have the door modules, which we put inside of the door of that room. And next to that is our human detection modules, which we place it forward the entrance to detect hip movement. And this is where the light of the room should be, since we cannot mess with, interfere with the room electric system. So we have to use our own light here, and the light sensor directly opposite to determine if the light is on or not. And in the middle of the room, we have this central hub here where we store all of our microcontrollers and a single board computer. We also have a camera system to take view of the room. And next is temperature sensor, really close to the air conditioner to determine the temperature of the room. And lastly, it is the AC control. This is how our system should look like in real deployment. This is our door sensor. In real scenario, we would put this component inside the door, not outside like this. However, the way we put it like this to demonstrate how the component is placed and be controlled. This is how we place human detection and eye control. And that is the light we set up, our light sensor. In the middle of the room is our camera system. That's our temperature sensor. That is our AC control component. This is how we deploy it with all the cables. This is the door component. Here we demonstrate how the door component works by placing the two mic finger inside of the component, pressing against it. The way we lock the door, we lock the door, the deadbolt of that lock come out and press against the component, which gives me the status of when the door is locked or not. This is the power source of our light, which is connected directly to our light control component. Along with that, we have human detection here. All these cables then connected to our central hub module is in the middle of the room. I would like to introduce you to our mobile app, which the user will use to interact with our system. Each of the users that have our system will be provided with an account that they can use to interact. Here we have the room list that the user have that the room that have our system in. When choosing a room, the user can see all the status of the component that we install for them. The user can also see all the images that captured by our system. They can also set schedules for air conditioner and light system with either on or off or both. So they can delete their own schedules. Along with that, they can modify the schedule that they set before. The manual control is where the user can interact with the system through mobile app. First is control AC. First of all, when choosing AC, there is a pop-up that show the user that the temperature inside that room and ask the user to either turn on or turn off the air conditioner. In this example, we turn off the air conditioner by our mobile app. And here by pressing turn off, the wing slowly goes down. And here's the example to turn on the air conditioner. The wings here are slowly turning on. Okay. The same goes for light system. The light is turning on and off. Auto control is the system way of interact with the light and AC system through a schedule, not by hand. So we have here, we set up a schedule to turn off the air conditioner at 4:25 p.m. We have here is 4:24 already, so pay attention to the wings. So at 10:25, the swing is slowly closing down as intended. Another example of turning on the air conditioners. Yeah, for 10, we turn on the air conditioners. The same goes for our light system. Here. Config. Next is the config features of the system. So to every set hour, the system will take image of the room and check all the component status and notify user if any of the component is not turned off. This is how we detect there is a person inside the room. Next is door notifications. When the unlock door event is where there is no one in the room, and when the config time hit and the door is not locked, the user will get a notification like this. Human detection. Finally, it's about human detection event outside of working hour. In the video, when a person walks through the movement detector, the surveillance system will capture and send notification to user through mobile app. In here, the user can access gallery and see the image. That's all for our video demo. Next, we will present our project artifacts. Thank you.
So this is how our system works based on Min's demonstration. So now we move to the project artifact sections. The first, we choose Agile as our main project management methodology, specifically Scrum framework. However, we had adapted something to suit our project because our project is quite new to all the team. So in detail, we broke our project into every one sprint week and with 15-minute daily meeting and a sprint meeting at the end. So every sprint meeting is recorded to a meeting minutes. By arranging like this, we can quickly get new requests from the customer and also change tasks to suit it more quickly. So when we meet our supervisor at the end of the sprint meeting, we need to report it on what we had done on the previous sprint and the difficulties in the process. Therefore, if there are any difficulties, we can get quick advice from the supervisor. And if there are any changes from the client or from the supervisor, or if there is anything that we need to change for our system, we can also notify the customer very faster. We use Trello as a tool to track tasks and events first. We note it down every meetings with the supervisor, clients, experimental records, deploy and setup, and our task tool. So develop and test each of them until the final phase we deploy and test. So in the first phase, we kick off. The phase includes meetings amongst our team and we set plans that we had discussed with our team in our rooms with the supervisor, with the client, and we would analyze the requirement and work on the project proposal. For the second phase is the door controller and mobile app. In here we just researched, created and tested modules and our modules for our door controller device. We also spend time in designing UI UX and picking out an appropriate programming language for mobile app. Phase 3 is surveillance device and Android app. We research, design module and testing surveillance device. We would also start developing on our mobile app on Android platform. And the phase 4 is for electronic device and mobile app on iOS platform. And the final phase is deploy and test. Throughout this project, we have approached and learned many new technologies and tools. For mobile app, we use Swift and Swift UI framework, coding on the Xcode IDE for iOS platform, and Kotlin on Android Studio IDE for the Android platform. For the backend and server, we use JavaScript as our main programming language, utilizing Node.js along with RESTful API, Linux environment, MQTT protocol, and MongoDB for the database. For IoT, C++ is the main programming language and was made in the platform I/O combined with Node-RED, which is a prototype tool. We also utilize Python to operate YOLO V5 to detect human presence in an image. For design, we use Blender for 3D model design and Figma for mockup. Besides those technology, we also use like Trello, AutoCAD, and Photoshop Premiere and Sony Vegas for other purposes. So this is our architect and flow of the system. Each user first interact with the front-end component of the system, which is the mobile app. The application will initially obtain the required data from the API before engaging with the system. The mobile application will communicate with the server through an API or with a central hub through an MQTT protocol. Depending on the function it offers, the MongoDB database will be used to store the data collected from the system, and the Google Drive will be used to store the image captured from the system. In order to run the cloud and domain name with SSL certificate for the application, the system is also integrated with the service provided by third parties. And finally, the result will be shown on the mobile app to the user. During the system development, we have 6 groups of testing, including 3D model, front-end, back-end, devices, model, and mobile app. For 3D model, we use it for testing whether the actual design after printing is fit the component or not. Front-end is used for testing whether the design actual product is logical or not. For back-end, we tested why implement function during our developing server and backend side. The devices are used for testing whether the sensors, when putting it, whether the sensor can be used or not, and the code can be applied to the microcontroller so that it can be run as intended. And the module is used for testing whether, when putting a sensor into a 3D model, the component still works well. And along with that, it is also to check the real situation performance for that component. And finally, the mobile app is used for testing to check if the function in the app can run smoothly and continue will be kept for the remainder.
And the following slide is about how we address all the significant documents for this project. So it contains 7 main parts. The first one is the research and development section. Well, it's all about what we have analyzed
and research in this project to meet the needs of the client. And all that is for the project proposal, research in technical design, user guide and user face design, and last one is 3D model design. Well, after we research, we need to plan. So the planning and control the document provided in that. We keep track everyone work log by individual work log, weekly work log, and release plan. And since we apply agile methodology and a Scrum framework, it's significant that we need to think of how we communicate each other effectively among team members, client, and even the supervisor. We do that by meeting minutes, weekly reports, and communication plan. And after we make some products, we need to ensure that our products need to perform well and functional properly. We do that by warranty control and assurance. And it contains room layouts, experimental records, and test case. And finally, we have a final product, and it contains a video demo, a short code, and the last one, the presentation poster, and the other diagrams and report. Well, to summarize this project, I will tell you about what we have learned, achievement, and also the challenges. First one is what we have completed. And we have successfully done server, cloud, backend, and device work perfectly together and connect to the mobile application. And all mobile applications for Android and iOS platform are complete and ready to upload onto the App Store and CF Play. And to client, we have successfully solved the problem by develop assistant electronic devices simulation system. And for team, we gain some significant professional experience in a new field, the Internet of Things, IoT, and gain knowledge and skill to prepare a professional mindset for a future career path. However, when we do a project, not always we can perform well like as we planned it. There's still some obstacles. The first one is we have to adapt new area and knowledge. Trial and errors due to the lack of experience and knowledge can always happen. And it will cost time and resources. The lack of support in documentation and community of the MQTT protocol for the mobile side and the backend side. And for the deployment, we have to face several difficulties in setting an up device and due to the size of the room. Yes, the G2 room is quite kind of big. And we have the wiring process is tedious and laborious to do. A component, every design for each component needs to be print and test for many versions, and even we have to make some error for dimension inside. And each component went through trials, error to find the right sensor. And since it's the first time we joined this field, we have no prior experience in 3D design and 3D printing. Furthermore, we could face a problem for the 3D printer. And finally, it's a future plan. But in the near future, we will deploy 2 mobile applications for Android and iOS platforms to the store. And more functions for users in mobile app like display and change user information. Allow users to add new room and new device. And we will allow users to download, save, and delete images in the gallery. And also allow them to control the camera manually like the AC and the light. And for long future, we will develop this system to be production ready. And the next one is the team contribution in general. So we have add like infrastructural design, tester, and 3D design. And Lynn is a project manager and mobile developer. But will act as a backend developer. And Phúc is an infrastructural designer and tester, and even the tester for the mobile app and 3D design. So that's the end of our presentation. Thank you for listening.
the,
and IC controller.
is it a demonstration, right? This IC, this our switch. This only connected to the cables that control the light. This the IC which have an infrared LED to control, to send signal, to replicate as the IC remote to send signal to the air conditioner for them to behave as we like them to be.
You have to control the air conditioner.
Yes.
So I have different brand of air conditioner.
Yes.
Okay.
We have program that we have many popular AC brand inside Vietnam. So here is two buttons. So when we don't have to use the app, you don't want to open the app, it's too long or something. We have a two button here. You can either turn on or off the air conditioner using this button, or at first you brought this project home with you. You can look through all the popular brand in Vietnam to see if any reaction coming from the air conditioner. If yes, release the button, then it is forever inside of the microcontroller to know that this is your air conditioner brand.
Yeah, but how can they control the air conditioner on the phone? You can increase, turn on, off, change the light, or the intake.
Oh yes, that is the features that we planning to do because with each air conditioner they have something like vertical swing, horizontal swing. So all the air conditioner don't have any of them. So the most we can do that be close with the universal remote is we can control the temperatures, turn on, turn off, the swing of the air conditioner,
Now this controller can do it. Just on off.
or just on off. But the app can do it.
So it's the same feature with the line, on off the line,
Yes.
on off the air conditioner.
Yes.
No, the difference between AC and the light switch is because the AC you can do it by yourself, depends on the buttons here. But for the light switch, you just only do it via our mobile app.
Okay. So if they have the symbol feature like this, I will like the one like plug-in and just put the power inside. Then I can turn it on and off. That means I disconnect, I can connect the power. So I can turn it on and off.
Oh, you can do that, of course, and we can do that. But the way we split down our modules smaller than this because if you what happened if you only this room you have everything here, but the next room you only want the light switch. So you have to combine these two. If you say like that, you have to combine these two. It is no longer needed for the room that you don't want to control the air conditioner in.
Yeah, no. But in my home, I buy plug-in and I plug it into the power for the air conditioner, the power for the light, and the power for the other device. So I just remote from the app and turn it on or off. I just disconnect or connect to the power. You got my idea?
The button you use, we also use that plug, that plug connected directly to our Raspberry Pi, and this power all three microcontrollers.
Yeah.
So it is extra step for us to control with the same function like that.
Okay.
So the microcontrollers, that's what I don't see here. So each mic is the colors, like you have one microcontroller for door and the movement, or one color, and then the other one for the AC. Okay.
So here is the microcontroller we use.
Okay.
We place it in here, so it is not available on the video demo.
So why Raspberry Pi? Why not the small controller or central control?
Oh yes, we use the Raspberry Pi for YOLO V5 to detect the person inside a picture. So
system and let's try on the scenario.
Yeah,
So
yeah.
for example, I turn off the power of heaven of your system.
The whole room.
Yes? What happened?
Nothing will happen because there's no.
So for example, you have the lock in the door. So what happened if in the emergency case, so the power is off? So what happened? I cannot open the door and
No. We don't control the door. We don't even control the deadbolt of the lock. We only detect if it locked or not. Because to really control the door, we have to replace the whole door, have our own deadbolt to lock it ourselves or remotely.
how can you know the door is locked or not?
Oh yes. So here is our door.
Yeah.
So before we lock, it is fully extended. So there is nothing pressing against it. So when it lock, the deadbolt hold it right here. So it does fully extend. So using that, we can know that either the door is unlocked or not. When they unlock the door again, it's fully extend again.
When I want to install this one to my door.
Because it's for just the iTech goes only. iTech goes only.
Yeah.
Because I have knowledge in this field, just want to ask, what is your estimated cost to set up one system with this chip or one system?
For you or for us?
If you plan to develop into production ready situation, in that case, moving to the market, estimation of how much will be the market sale of one code system, like one
Because we spend over 10 million for those systems. We nearly 20. So I think, but because we need to spend a lot for the testing and the trials, and we need to for the outsource for printing too.
Then you have two options. You can either buy one package like this, go home, you can set up for you, or you can pay a subscription. But it is less cost than that way. You can use as a subscription. You can pay this month by month until you are done.
You rent the line here, rent the
Yes, we will do all the setup, the maintenance, everything from start to finish. But they don't have to buy everything in 10 million, which costs more. Yes, yes, we do. You can choose your colors.
Because can you see that this is a new this is a new area to us. So every box, every container, something we need to measure the sensor inside. What will we put
interesting presentations. My name is Trevor from the Physics department. My question is, from my understanding, this equipment, the sensor should be placed next to or nearby the equipment, right? Nearby the line or nearby the ICs. So the question is, let's say, and the sensor will detect the temperature or the intensity of the line to say if the room still have, if the line is still turned on or off, right? So how could you distinguish between, this light is off, but the other one is still on?
This is our light sensor. So for this, we can adjust the sensitivity of this sensor. So either you want to check only this top of the room to turn on or off, you can twist to turn on the sensitivity of this sensor to detect closer or longer.
How far should be?
This part is really cheap, so I would suggest only 2 max.
The difference between two lights in this one is approximately 2 minutes. What if you place it in just in between of the two seconds, two rows of the lights?
So we
Or do you need one sensor for this one? Do you need one sensor for each equipment?
because we do research on each room that we deploy in, so we can know where to place this optimally. So at this point it is not very customizable where it should be placed, but we can place it where it can be optimal for the sensor to recognize the light density.
So how can this sensor connect with the hub? Would be the line,
Oh yes.
like this, connect to the Wi-Fi.
Yes, this microcontroller connect to Wi-Fi. We have.
However, the sensor.
Ah, yes.
So first of all, you put the sensor in the air conditioner there. So there will be a line linked to the hub. The sensor will connect through the Wi-Fi.
Here we have a connector.
Okay.
So this is a connector
Here is
between
the same as this. We have 2 male connectors to plug this in. So this is a plug-and-play system.
So if you need to increase or you need to add more light, you only need one box here, and just like that, look and play.
So you basically are boosting the change. No? So you need many sensors, how do you connect them? Okay.
So because I see on the video demo, there's a lot of line connect from the device, from the sensor to the hub. Yeah, right. Line network across.
Here connection, those line connector. And if we have more computers, we will connect it like parallel.
In each model, they have a 4-pin connector right here. And when you buy smart, we will provide you cable, 4-pin connector cable, to plug them to the central hub. Right here in the central hub, we got also the whole hub for it.
So if you buy this one, how long for the one? 1 year, 2 years, is this 1 to 3 months?
We responsible for maintenance this system.